Hello, this movie is for Unit 6, Learning Target 3-4. Use relationships within parallelograms. Parallelograms. Parallelograms have special properties regarding their side lengths, angle measures, and diagonals. So a parallelogram is a quadrilateral, four sides, with both pairs of opposite sides parallel. So you can see here, opposite sides parallel. In a quadrilateral, opposite sides do not share a vertex and opposite angles do not share a side. Now, notice here, you can abbreviate a parallelogram with that symbol. So if you have that symbol, you would call that parallelogram ABCD. Or you could put an S for parallelograms and then list another set. So just some notation you need to know. Our first theorem is if a quadrilateral is a parallelogram, then opposite sides are congruent. So if we have a parallelogram, then we can say that the opposite sides are congruent. Now, a parallelogram itself has opposite sides parallel, but if it's a parallelogram, then we can also say opposite sides congruent. Let's prove that theorem. This unit will have several proofs to it, some of which you can see here. I've given you the statements. You need to provide the reasons. Some I put in the notes, some you'll need to write down. Let's look at this. So here we have in the given parallelogram ABCD. So this we put given. AB parallel to CD, AB parallel to CD, and these two parallel by definition of parallelogram. Now, 1 congruent to 4 and 3 congruent to 2, because I have these lines parallel and it's cut by this transversal, 3 and 2, as well as 1 and 4, are alternate interior angles. So this is because alternate interior angles are congruent when lines are parallel. AC congruent to AC, the reason for that is because reflexive property. And now the two triangles are congruent by, it'll be angle, side, angle. AB congruent to CD and BC congruent to DA because corresponding parts of congruent triangles are congruent. CPCTC. And that's our proof for Theorem 6-3. Let's go to the next page. And we've got angles of a polygon that share a side are consecutive angles. In the diagram, A and B are consecutive angles because they share a side AB. The theorem below shows the fact that consecutive angles of a parallelogram are same side interior angles. So you can see here, if I've got two parallel lines like this, cut by this transversal, you could see that angle A and angle B are same side interior angles. Therefore, they're supplementary. And so you can see that listed here. Let's apply that over here. We've got a parallelogram PQRS. We've got one angle S is 64. What's the measure of angle P? Well, S and P are same side interior angles, so we find this by doing 180 minus 64, and we get 116. In the got it, suppose you adjust the lamp so that S is 86. What is the measure of R? Now you can see here that R and S are also same side interior, and we get that the measure of angle R is going to be 180 minus 86, 94 degrees. Okay, let's go down here. If a quadrilateral is a parallelogram, then opposite angles are congruent. So we get angle A congruent to C and B congruent to D. We've got a proof for that theorem here. I know that you probably don't have this in your guided notes, so I want you to pause the movie, add the statements, and then press play when you're finished. Okay, now that you've written down these statements, we're given that it's a parallelogram. So we've got BC parallel to AD and AB parallel to DC. This is definition of a parallelogram. Now, what allows you to say that A and B add up to be 180, B and C add up to be 180, and C and D add up to be 180? These are because same side, interior angles are supplementary when lines are parallel. And those are all sets of same side interior. Looking at line 4, what allows you to say that A plus B is equal to B plus C? And then to say that B plus C is equal to C plus D. Now notice they're all equal to 180, so this would be by transitive property or substitution. And then you could see in this first line, if I subtract angle B on both sides, I get A congruent to C. And then in the second one, if I subtract C on both sides, I get B congruent to D. So this is by subtraction, property of equality. And then going from their measures to saying the angles are equal, that is angles with the same measure are congruent. Angles with the same measure are congruent. All right, we're going to do another proof. Pause the movie, add these statements in your notes, and press play when you're ready to go through it. All right, we're given parallelogram, and we're given that AK is congruent to MK. So what allows us to say that angle BAD is congruent to CMD? Those are base angles to the isosceles triangle AKM. So this is by the isosceles triangle theorem. And what allows you to say BAD, this angle, is congruent to BCD? Because in a parallelogram, opposite angles are congruent. And it's given that it's a parallelogram. So now I've got these three angles all equal to each other, so I can do angle CMD congruent to BCD, which is what I want to prove, by the transitive property, because they're both equal to BAD. You can see that here and here. So transitive or substitution. And that's our proof. If a quadrilateral is a parallelogram, then diagonals bisect each other. Now a diagonal connects opposite vertices. So you can see that here. It connects B to D and A to C. Those are our diagonals. Now also notice that it's bisecting the diagonals. It's not saying that they're congruent. It's saying that AE is congruent to CE and that BE is congruent to DE, but BE is not necessarily congruent to AE. So be very careful. Let's look here. So we need to find the values of X and Y given parallelogram. Parallelogram tells us that these two sides are congruent x is going to be equal to y plus 2, and these two are congruent. Y plus 10 equals 2x minus 8. So I set those equal, and then I'm going to solve. So this is called a system of equations because you have two variables, two equations. X is equal to y plus 2, so I'm going to plug this in for x here. Do a simple substitution, and I'll plug that in. And I'm going to solve this equation. I got to distribute the 2 into both. Simplify this a bit. And then I'm going to subtract y on both sides. Add 4. And I get y is 14. So I plug 14 in here to get x. And I get that x is 16. And so I found the values of x and y that make this a parallelogram. Now, what's awesome is you can plug that back in and see that this is a length of 16. We can see that y plus 2, 14, that gives us a length of 16. 14 plus 10, that's 24. 2 times 16 minus 8. And so you can double check yourself by getting the lengths of those segments. Any questions, you'll just have to check with me. But we're going to go to this slide. Find the values of x and y in parallelogram at the right. What are PR and SQ? What I would like you to do now is pause the movie, try this on your own, press play, and I'll just give you the answers so that you can check yourself. So pause the movie, try this, and then press play when you finish. Alright, it wants to know what x and y are. I'm not going to go through the process because I did in the previous problem. But what we get is that y is 5 and x is 4. So then we could plug this back into our original, into the side lengths, and get that PR is going to be 15 and SQ is going to be 10. Okay. We're going to move on to the next page. Got another theorem here. If 3 or more parallel lines cut off congruent segments, so meaning this segment's congruent to this one, then they will cut off congruent segments on every transversal of those 3 parallel lines. So it will cut off congruent segments here and here. You can see that in the notation here. It does not mean that BD is congruent to AC. It just means that BD is congruent to DF, like AC was congruent to CE. So here we've got parallel lines. If AB, BC, CD are all 2, EF is 2.25. What is EH? Now EH is this whole length. So all of these will be 2.25. So if I did 3 times 2.25, I would get 6.75. So that's my answer. That's all you do. Let's try this one. Pause the movie, try it on your own, and then press play when you finish. So we know all of these are 6. We know AD, the entire length is 15. We don't know what these are. Can we get the length of CD? So I know that 3x's equal 15 because I can see them here. That tells me that x is 5, so I know that CD will be a length of 5. And that's all for this learning target. Thanks for